Okay. Recall the volume from A to B of A of x represents the volume of a solid where A of x is the area of the cross section and dx is the thickness of each piece. If the cross section is a circle, then we use the what method? Huh? Disk, yeah, disk method. The cross section may also be other familiar shapes of which we will calculate the area, thus today. So this first one is the cross section is going to be a square. And I had an applet that shows the stacking of this square. So essentially what this is we have a circle and then a whole bunch of squares are stacked. So I don't know if you can picture that. Well, you could do an equilateral triangle. They do a square. So just so you can picture the stacking here. This is a picture. It's not the same thing, but this is stacking equilateral triangle. So can you see the stacking going on? So picture the squares stacking. This is not the same example. This is an example coming up, but I couldn't get my thing to work. So I don't know what's going on here, but oh, there, it starts again. So you see it's stacking, 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 stacking. So this is equilateral triangles that they're stacking. So right now, we're stacking squares. So the square would start here and keep on stacking all the way across. Do you see that? All right. So how would we do this? You guys basically know how to do this. It's just the shape is different today, that's all. So how am I going to figure out the length from here to here? Because if I have that length, I have the height, and it's just s squared, right, for the area? Right, so the problem is right now it's in x squared plus y squared equals 1. So we need to solve for y first. So x squared plus y squared equals 1. Y squared equals 1 minus x squared. Y equals plus or minus the square root of 1 minus x squared. So the positive one is this part of the circle, and the negative one is that part of the circle. Does everybody see? So what would this length be from here to here now? Well, does everybody see that the positive value of the y from here to here is a length of square root of 1 minus x squared? So then the full length of the square would be 2 of them. Yeah, don't deal with the negative one because it gets all confusing otherwise. So I'm going to say the side is equal to the square root of 1 minus x squared. So s squared, sorry, times 2, yes, times 2. Yeah, so s squared is going to be 4 times 1 minus s. Okay, so the next thing we have, so now I have the area of one slice. Does everybody understand that? Okay, so now I need to figure out how far I'm stacking them. Okay. So I'm starting from this or here to here, so I need to figure out what that is. So here's the thing, like this is a unit circle. That should be a clue. Yeah, it is 1 and negative 1, yeah. So this is 1 and negative 1. So we're just supposed to know that? Yeah. Yeah. 1 equals, in fact, what you're supposed to know is formulas for circles is, you know, x minus h squared plus y minus k squared equals r squared. So when it gives you this 1, that's actually r squared. So the radius is 1. X minus h squared plus y minus k squared, where hk is the center of the circle, and r is the radius of the circle. That was one of the enrichment topics that, I don't know if you did do it. Okay, so I'm going to pull out the 4, and then I'm going from negative 1 to 1 of 1 minus x squared dx. Is everybody good with that? Because the thickness would be dx, right? I had the area times the thickness, right? Okay, so does everybody see what I did? Okay, so so this is going to equal 4 bracket. If I add 1 x to that, so I get what? X minus 1/3 x cubed from -1 to 1. Yes? And just for time's sake, I'm going to give you the answer. Is that all right? Because honestly, at this point, you guys know how to sub it in and do all that. Okay, so 16/3 is your final answer. Well, and that's the thing. Once you start reviewing for the exam, you'll look at derivatives and go, and look at some of your tests and go, oh my gosh, that was so easy compared to what we just did, right? Yeah.
Well, because we know all that now.
I know. I know.
Retook the derivatives test. I wonder how much better everyone wanted to go.
Yeah, well, we'll see, hey? Okay, so now we're doing a cross section of squares. Same thing, square. But this time it is a parabola. I know. So we have a parabola. It's nicely drawn for you. And we are stacking these squares. Okay, so can anybody tell me some information about this? No, it's a parabola, right? It's an upside down parabola, right? Can anybody tell me where I'm starting from and stopping? That would be the x-intercepts, plus or minus 1. X-intercepts, right?
Wouldn't it have made sense to stack squares starting at the y? Wouldn't it make more sense for this question to start at the y?
Okay, so you can, we'll see some questions stacking the other way.
I'm saying for this shape, it'll probably fit better for a square if it's started the other way.
I don't think so. I think it'd be the same, right? Because all you're doing, it doesn't, yeah, honestly, it doesn't matter because all you're doing is, wherever it ends up being the curve and the axis, that's just how long your square is. And so, I don't know if you saw this part of it. You can see my things, they're all varying widths, right? They're stacking on. So wherever that is, that's how big it's going to be that they're making. You know what I'm saying? So, anyways. All right, so we got where it's started from, where it's ending. How about this length right here? What is that length going to be? It's just the y value, right? And what's y equal to? 2 times, yeah. Yeah, so y equals 2 times 1 minus x squared. I don't know why the 2's factored out of there, but whatever. So that means the side length is 2 times 1 minus x squared. So the area of the square is s squared, right? So that would be this whole thing squared. So maybe I'll write this out so you can see. This whole thing is squared. So watch that. So what do we get there? The 2 goes to the this power 2 goes to this 2 and to this bracket here. So this is a FOIL times 4. Do you see that? So this is 4 times 1 minus 2x squared plus x to the power 4. It's up to you if you want to multiply the 4 in, but really you're going to pull it out of the integral anyways, right? So there's no point. So what's the thickness? What's the thickness? It's dx, right? Yeah, and we're going from -1 to 1, and I'm going to pull the 4 out, and this is 1 minus 2x squared plus x to the power 4 dx. Everybody good with that? Okay, we'll just do the next step, and then I'll just give you the answer. So this is 4 bracket. This would become a x. This would become a minus 2/3 x cubed, and then this would become a, and that's from -1 to 1, and my final answer is 64/15.
A lot of these just going to be practical.
Yeah, it seems that way, but just because of the way, the natural way it's going like that. So you guys know how to change decimals into fractions, right?
Easy decimals.
Yeah. No, on your calculators, just frac,
yeah,
enter. Yeah, okay. So just making sure.
I talked about just in general.
Okay. Second page. We're doing good. Okay. So, hey, it's still, oh, no, this time it is a semicircle on a semicircle. Pretty cool. So we're stacking a semicircle and a semicircle and a semicircle and a semicircle going like that.
So, like a croissant.
Actually, yeah. Yeah, it is.
Okay. So, how are we going to figure this out? Some things we know. Where are we stacking from and to?
Wait, the area of a circle is pi r squared.
Yeah, so the area of a circle is pi r squared. Yeah, so a semicircle, area of a semicircle would be pi r squared divided by 2. Yeah. So what else do we know? The x-intercepts would be where I'm starting and going to. So does anybody think they can just quick mental math figure out what this and this is?
Is it 1 and oh,
Yeah, it is 1 and negative 1. What? No, but if you set 1 minus x squared, so does everybody see what I'm doing here? I'm setting it equal to 0. I'm squaring both sides. 1 minus x squared equals 0. 1 equals x squared, so x equals plus or minus 1. That's what I'm doing there, right? It's not, I'm guessing then. Because you won't have the graph necessarily provided for you. I'm just kind of doing that.
So the
For you.
radius would be
Oh, yeah, let's do that.
1 minus x squared.
Okay, so remember, I'm going to do a different color here. Now, this is the tricky part here. So, here's your circle here. So, does everybody see the radius is actually from here to here? Okay, so now, so if you think about that, do you see, I'm going to use a different color again. If you think about that for a second, you do know this radius right there. So what would that? Well, the radius is whatever this is right there. So this is going to be half of that. So the radius is the square root of 1 minus x squared divided by 2.
how do you know it's half?
The circle.
So it's saying it's a semicircle and I'm stacking a semicircle. So although maybe I didn't draw it that it looked like a half, from here to here, this radius has to be the radius, right? And so because this is from here to here, and that's a semicircle, like if you were to stack it, that would be the other part of it, right? Like if I shimmy it there, it's pretty noticeable. It's half of it. But honestly, it doesn't really matter in the fact that if this is a semicircle, this is the diameter. No matter where this is the diameter. Do you know what I'm saying? So this semicircle's diameter is this semicircle's radius. Can you picture it now? It doesn't matter where I stack it, but I just thought it'd be easier if you look at it here compared to if I stacked it there. But I think I think Carson understood it better where this radius here is this diameter for that semicircle, which means it has to be half.
Yes, it's just.
It is, but it's all relative, right? So if it's over here, right, that's...
It's the y value.
It's hard to explain, yeah. Yeah.
The y value.
Like, as a circle side, like they,
So then r squared, if I just want to simplify things, r squared would be,
1 minus x squared.
this would be this whole thing divided by 2 squared, which is then 1 minus x squared over 4. Yeah? Okay, so, and then if I want the area of a semicircle, is going to be pi times 1 minus x squared over 4 over 2. Yeah? So I'm going to pull out pi over 8. Are you okay with that? Because this whole part is the constant.
Wait, isn't it 1 minus x squared over 4 squared?
No, I already squared.
Oh, yeah, sure.
I already squared it. So that was that part that I actually found. So essentially, I'm timesing it by pi over 2 right now. Okay. So my volume is going to be stacked from -1 to 1. I'm going to pull out the pi over 8 to make it easier, right? And then this is going to be 1 minus x squared dx. Okay, well, no, everything's good. So anyways, so yeah, let's just keep on going. Pi over 8, and this is x minus 1/3 x cubed from -1 to 1. Well, we can do this one if you want, just to make sure. So this is pi over 8 times 1 minus 1/3 subtract -1 plus 1/3, yes? So then the 1/3 will actually, no, they don't cancel. Darn it. Yeah, they all add up together. So then I get pi over 8, 2 minus 2/3, right? Yep. Right. 2 minus 2/3 is 1 and 1/3, which is 4 over 3. So pi over 8 times 4 over 3. Yeah, and I get pi over 6. All right. Hey, this is the one that actually worked. Did you want to see it again? Did you want to see this one again or no? Yeah. Okay. At the base, okay, so this now is a sine x, so it's a wave, but it's only from 0 to pi, so it's like a one little, it's not the continuation, right? And then the cross sections are equilateral triangles. Now here's the thing. If you memorize the formula for area of an equilateral triangle, by the way, does anybody know it by chance?
I feel like
It's something kind of weird.
No, equilateral triangle.
Equilateral triangle, it has to do with 60s and all that, right? Because, so then if you think about all your trig, to get the height of it, no, actually there's no sign in there at all. So you need to put this on something you have to memorize or whatever. Area of an equilateral triangle, because they'll ask you equilateral triangles all the time, is equal to root 3 over 4 a squared. A is the one of the sides. Yeah, no, and I could totally prove to you where this comes from, because you know base times height divided by 2 is the area of a triangle. So because they're 60-degree triangles, the angle sine of 60 is root 3 over 2, and that's where they're getting the root 3 over 4 because of the half. Do you see what I'm saying? Yeah, so that's where it's all coming from. So if you memorize this, then you don't have to actually do all that trig to figure it out. You just use that and go on your merry way. Any side length. Well, because the equilateral, right? Yeah. Okay, so let's see the stacking again. There's it again. I'll have to wait till it starts again.
Yeah, how do you find the area of what's the triangle for you inside?
Sorry, does everybody see now it's going again there? Okay, what are you asking?
Find the area of a triangle that has all the sides.
Well, you'd have to have the base and the height.
No, but like it's not.
Oh, yeah, I don't know it. You'd have to Google it. Okay, we're good? So you can see the equilateral triangle stacking. Okay. So we might just do this one on the calculator, to practice doing it on the calculator too. Okay, so what's going to be the length? I'm going to draw this triangle. What's this length right here of the triangle? Sine x, yes. So A is sine x, because it's whatever the y value is, right? Yeah? So big A is going to be root 3 over 4 sine x, the whole thing squared. So what do I get? Root 3 over 4 sine squared x. Yes? Okay, so now we have to figure out where we're stacking to and from. Nope. Fine. So this is actually a pretty simple question because it's pretty much done for you, right? Except knowing what area of an equilateral triangle is. So volume is going to be the integral from 0 to pi. I'm going to pull out the root 3 over 4. And this is going to be sine squared x dx. Now if we were to do this by hand, does anybody remember what they had to do to integrate sine squared? You're supposed to use the half angle, that 1 minus cos squared over 2. Yeah. Yeah. So, and then so 1 minus cos 2x over 2. And so then you can, yeah, you should have that on your thing, because they may ask you to do this by hand. So what you'd have to do is you need to change this to the identity 1 minus cos 2x over 2. I'm sorry? Oh, pi, yeah. Yes. And then you integrate that as with u substitution. But you could probably just look at it and not even do u substitution. Yeah, this is an integral sample. Yeah. Now it looks like a violin. No, this is not the antiderivative. This is just an identity switching. If you were to do this by hand, that's what you'd have to do. Okay, so let's punch this into our calculator and see. And if you want, just for fun, let's punch this into our calculator, and we should get the same thing because that is the identity. So I'm just going to pause it while we figure this out. Okay, so it's like I said, it's much easier putting y1, the sine squared into y1. You just got to watch all the brackets, because remember, if we look at how the brackets work here, it'll impose there. You'll have to close this. So that's my y1. And then to prove to you that this is the same, and this is how we do it by hand, it would be the 1 minus cos 2x over 2. So make sure that's somewhere on your thing to memorize. Sine squared x is 1 minus cos 2x over 2. Or you could have 1/2 factored out, bracket 1 minus cos 2x, which is easier because then when you're integrating, the 1/2 would just be taken out of the... So this should go on a card, and this should go on a card. And you should have cos squared on that, and that would be the plus. Yeah. Maybe if you're doing, yeah, if you're doing some cards, do this too, because you never know when that will creep up too, because that's how you're going to integrate it by hand, right? So, all right. So apparently this is not in your notes, so this is your example 5. Okay. So this is actually taken from a AP exam, yeah. You can tell by the way they asked it.
Yes,
The diagram, everything like that. Okay, so let's read the whole thing. Let R be the region in the first quadrant bounded by the graph G. So G is this right here. And R is this section there, yeah? Let S be the region in the first quadrant between the graphs of F and G. So I'm going to use a different color. So that's this part right here. You see that? The region in the first quadrant bounded by the graph of F and the coordinate axis is 12.142. So what did they actually give you there when they give you that? What did they actually give you? The area of that region bounded by F, which is this top part, and the coordinate is 12.142. What are they giving you there? Does everybody see that's the area of S? So I don't know if you heard what Josh said, but this 12.142, that's the area of S plus R. Does that make sense to you? The function g is given by g of x equals the square root of x plus 6 cos pi x over 8, and the function f is not explicitly given. The graph of f and g intersect at 4, 0, which is this point right here, right? Find the area of S. So how are we going to do this? Yes, does everybody see if we figure out the area of R and we subtract that from 12.142, we will get S. So how are we going to figure out S is going to be 12.142 subtract. How am I going to figure out the area there? Oh my, we don't know? Thank you. The integral of g of x from what to what?
0 to 4.
0 to 4. Okay, and on an AP exam, because g of x given in the question, I would not write out g of x. Just write g of x, not this whole thing. That takes too much time, right? Okay, so this is a calculator, graphing calculator 1, so it's legit to use a calculator. So we're going to put g of x into y1. So I'm just going to clear this out of there. Again, this takes practice punching it into your calculator. And I found a worksheet that has all calculator questions, just how to punch different things in, because honestly, every year, because we don't use a graphing calculator a lot till the end, there's still some people that don't know how to use it properly, right? So I got to close that. And then I got cos. I don't think I needed that extra bracket there, but I had it to start with. So, so this is pi x divided by 8. Okay, we're good? So now I'm going to quit out of there, and I'm going to go 12.14. Let's try that again. 12.124. Subtract. Oh my gosh, it is 142. Thank you for catching that. The integral. Are we trying this, people?
Yeah.
You already got the answer. I'm sorry. Okay. It takes, yeah, show-offs is right. So I know. Thank you for feeling sorry for me. Is that what you got?
Yes.
Okay. So, all right. 5.2039. Remember, I always do 4. It says corrected 3. Do more. It's all good. Okay. A solid is generated when S is revolved around the horizontal line y equals 5. So I'll just give a picture. Here's 5. And so it's saying S, which is the red thing, is getting rotated like that. So if you, I don't think it actually touches it there, does it? Huh? Yeah, it's a washer. Yeah, no, it's a washer. So it says write, but do not evaluate. You know why we can't evaluate? Because we don't know what F is, right? Yeah. So write, but do not evaluate an expression involving one or more of the integrals that gives the volume of the solid. So yes, this is a washer. So I don't know if you had a chance to do your washer homework. So if I'm rotating this around here, what is my outer radius and inner radius? Yeah. So does everybody see my outer, my outer radius is going to be, that's my outer radius and that's my inner radius. That's rotating. Okay, so now for the hard part. And I think this is the part of the video that you didn't see, you'd have to watch, right? Because this was a question that I never got to in the last video. So, and it's not like it's hard, it's just you have to picture what you're figuring out. So the radius, how do I figure out that length right there? Sometimes if I draw it out here, I'm going to draw it out here. So here is like that, and here is that. And this is 5 from here to here, just for a picture. And what's this length from here to here? Whatever g of x is. I'm just going to call it g. So what's this length from here to here going to be? 5 minus g. Does everybody see that? It's not that hard. It's just you have to be able to picture what's going on there. So big R. Oh, sorry. Maybe I'm going to write it over here. So big R is going to be 5 minus g. Okay, so I'm going to draw a different picture. This time I'm going to do the smaller radius. So I'm going to do it here. I have it like this. And here's my 5. And here, so this length from here to here is 5. This length from here to here is f. So what is that length right there? That's my little r, right? And what would that be? 5 minus f. And then the formula for the washer has to do with the pi and the 2 radius squared, then subtracted, right? Not subtract, then square. So, am I good there? Yeah. Okay. So, what's my volume is going to be the integral from what to what? I forgot already? 0 to 4? And there's going to be a pi in there. And what's my big radius? Squared? I'm going to do big square brackets. So it's going to be 5 minus g of x, the whole thing squared, because this is my big R. Subtract bracket 5 minus f of x. Whoops. 5 minus f of x, the whole thing squared, dx. Yeah, don't forget your dx. Okay, so just so you know, if you forgot where the heck these are all coming from, this is coming from volume equals pi from a to b of big R squared minus little r squared dx, yeah.
So how come that one would be dy? Rotating across like up and down.
It's rotating around line.
It's rotating around this, so yeah, it's not a horizontal slice, right? It's a vertical slice. So the vertical slice is the measure of the change of x, which would be dx, right? Okay. So do you see how these AP questions are all put together? They're like everything, and they might have had something back in there with A had to do with the derivative of some sort. So it's all everything we're learning. That's why I thought this was a good question to have on here. Region R is the base of an art sculpture. At all points in R, a distance x from the y-axis, the height of the sculpture is given by h of x equals 4 minus x. Find the volume of the art sculpture. So here we have, what did it say? R. So we're looking at R. And they're saying, so we're having some, whoops. I don't know why that went all wonky. Maybe I should just do undo. So this is, it's kind of hard the way they have it, I'll do a different color. So they basically have something here coming out like this. I know the people watching the video can't see this, but this is coming out of the wall, and the height of that is 4 minus x. So the height is 4 minus x, and this base is going to, it's not a square, right? It's, the height is 4 minus x. So it could be, well, because it's 4 minus x, it's going on a diagonal, I guess, right? Maybe a kind of like a, right? And then this height is, of course, IG. So length times width would give me the area of that object. Yes? So can we come up with the integral? So we're going from 0 to 4 again. Remember the length was g of x? And my height is going to be 4 minus x dx. And we already have our g of x in our calculator, so we're going to see what that is. I know you guys will punch it in faster than me at this point. So okay, so
I'm done before you.
stop it. Okay, so my g of x was my y1. So this is going to be math 9. Yeah, see, some of you guys are even better at the calculator keystrokes than me at this point. But I do, using a mouse to do this does. So of course this is times bracket 4 subtract x, and then comma x, comma 0, oops, comma 4, bam. Did you get that? Okay, so it is. So this is 17.2433.